The morning light filtered through the tall windows of the Messerschmitt factory in Regensburg, casting precise geometric shadows across the workshop floor. Hans Weber adjusted his wire-rimmed glasses and leaned closer to the aluminum wing section before him. Every rivet hole had been hand-drilled to tolerances measured in fractions of millimeters. Every surface bore the mirror finish that was the hallmark of German engineering excellence. Perfection, he whispered to himself, running his fingers along the wing's leading edge. This was not merely an aircraft component, it was a testament to 2 centuries of Germanic craftsmanship, a mechanical poem written in duralumin and steel. Weber had spent the last 3 months perfecting this single wing design for the Bf-109 G6. Each curve had been wind tunnel tested dozens of times. Each structural joint had been calculated and recalculated by teams of engineers with slide rules and differential equations. The result was a masterpiece that would have made his father, a precision toolmaker who had helped build the legendary Zeppelins, weep with pride. The sound of precision machinery filled the air like a mechanical symphony. Weber closed his eyes and listened. The rhythmic tapping of pneumatic hammers, the whispered hiss of compressed air, the melodic whir of lathes turning aluminum stock into components so perfect they seemed to have been carved by the gods themselves. This was the temple of German engineering, and Weber was its high priest. Herr Weber, a young technician approached, clipboard in hand. The morning production report. Weber took the clipboard without looking up from his wing. 23 Messerschmitt fighters completed this week. Each one a jewel of engineering, each one representing hundreds of hours of skilled labor by craftsmen whose fathers had built the machines that had made Germany an industrial powerhouse. Excellent work, Friedrich. Weber said, finally looking up. Tell the men their precision continues to honor the Reich. But as Weber handed back the clipboard, Friedrich's expression remained troubled. Hey, Weber, there's something else. The Luftwaffe intelligence reports. Weber frowned. What about them? The Americans, sir. Their new fighter, this P-51 Mustang. Our pilots are filing some unusual reports. The factory sounds seemed to dim around Weber as Friedrich opened a leather folder. The reports were typed on official Luftwaffe letterhead, but their contents made no sense. Major Klaus Brenner, one of their most experienced aces with 47 confirmed kills, had written, the American Mustangs appeared in formation at 25,000 feet. Their speed and climb rate matched our own Bf-109s. But what disturbed me most was their numbers. Where we expected 6, there were 18. Where we expected replacement aircraft in weeks, they appeared in days. Weber shook his head. Brenner must be mistaken. American aircraft are crude, mass-produced machines. They prioritize quantity over quality, which is why they cannot match our engineering precision. But Friedrich turned to another report. This one from Hauptmann Gustav Müller. Shot down 2 P-51s over Frankfurt. Expected to find roughly constructed aircraft with poor workmanship. Instead, discovered machines with surprisingly effective design. Simple, yes, but functional. The American pilot I interrogated claimed his squadron received 12 replacement aircraft last week alone. 12 aircraft. In 1 week. Weber felt something cold settle in his stomach. And 12 aircraft in a week? That's impossible. A properly engineered fighter requires months of precise assembly. There's more, sir. Friedrich's voice was barely above a whisper. Colonel Hermann from High Command has ordered us to analyze a captured P-51. It arrived this morning. The sounds of the factory, his beautiful, precise symphony, suddenly seemed very far away. Weber followed Friedrich through the workshop, past the stations where skilled craftsmen bent aluminum with the care of sculptors, past the quality control stations where every component was measured 3 times before approval. In the far corner of the factory, under harsh electric lights, sat something that made Weber's breath catch in his throat. The captured P-51 Mustang looked like a predator at rest. Its lines were clean, purposeful, but there was something different about it, something that Weber's trained eye immediately recognized, but his mind refused to accept. It looked efficient. Not elegant in the way a Messerschmitt was elegant, with its flowing curves and jewel-like precision. This American machine had been designed with a different philosophy entirely. Where German aircraft were symphonies, this was a tool. Where Messerschmitt fighters were art, this was engineering stripped of everything except function. Weber walked slowly around the aircraft, his engineer's mind cataloging details. The wing construction was simpler than anything they would dare attempt. The fuselage joints were adequate. Just adequate. Nothing more, nothing less than what was required for the aircraft to fly, fight, and most importantly, to be built quickly. Mein Gott, Weber whispered. It's like they built this machine to be mass-produced. Friedrich nodded grimly. Colonel Hermann wants a complete analysis, Herr Weber. He wants to know how the Americans are building so many of these so quickly. Weber removed his glasses and cleaned them slowly, a gesture he made when his mind was racing. In the distance, he could hear the familiar sounds of his craftsmen at work, each one creating mechanical perfection, one rivet at a time. But now those sounds carried a different weight. For the first time in his career, Weber began to wonder what if perfection itself was the problem. He looked at the P-51 again, and something in its brutal simplicity whispered a question that chilled him to the bone. What if being good enough but available in vast numbers was better than being perfect but rare? Weber pushed the thought away immediately. It was heretical. It went against everything his father had taught him, everything German engineering stood for, everything that made them superior to their enemies. But as he stared at the American fighter, he couldn't shake the feeling that this crude, simple machine represented something far more dangerous than any weapon. It represented a completely different way of thinking about warfare itself. Friedrich, he said quietly, clear my schedule for the next week. I want to understand this machine completely. Yes, Herr Weber. And Friedrich, I want complete discretion. What we discover here may change everything we think we know about aircraft production. As the young technician walked away, Weber remained alone with the captured Mustang. In the growing silence, he could almost hear it mocking the careful precision of his factory, whispering secrets about mass production and strategic thinking that he wasn't sure he wanted to learn. But he would learn them, because Hans Weber was, above all else, an engineer. And engineers, even German ones, had to face the truth, no matter how uncomfortable that truth might be. The first cut into the P-51's aluminum skin felt like sacrilege. Weber held the precision saw steady as it bit through the fuselage panel, exposing the internal framework that would reveal the American aircraft's secrets. Around him, his most trusted engineers, Heinrich from structural analysis, Klaus from propulsion systems, and Werner from manufacturing, watched in silence as decades of German engineering orthodoxy prepared to meet its first real challenge. Remember, Weber said, his voice carrying the weight of scientific objectivity, we approach this with open minds. We are engineers first, patriots second. Our duty is to understand, not to judge. But even as he spoke those words, Weber felt his chest tighten with anticipation. This examination would prove what he had always known, that German precision engineering was superior to American mass production shortcuts. The P-51 might fly well enough, but under close inspection its crude construction would be obvious. Heinrich was the first to lean in, his trained eye scanning the exposed frame members, his silence stretched for 30 seconds, then a minute, then longer. Heinrich, Weber prompted. This is, Heinrich paused, removing his glasses to clean them, the same gesture Weber used when his mind was racing. This is not what I expected. Weber moved closer. The internal framework was indeed simpler than a Messerschmitt's, fewer parts, fewer connection points, less intricate joining. But as he studied the design, something uncomfortable began to dawn on him. The American engineers hadn't made their aircraft crude. They had made it elegant in a completely different way. Look at this joint here. Heinrich pointed to where the wing spar connected to the fuselage frame. In our aircraft, we use 14 separate components to create this connection, each one machined to precise tolerances, each one requiring skilled assembly. But here they use 3 components. Werner finished, his manufacturing expertise immediately grasping the implications. 3 components that can be stamped out by the thousands and assembled by workers with minimal training. Weber felt the first crack in his worldview. But the structural integrity is perfectly adequate, Heinrich interrupted. Perhaps even superior for mass production, because fewer parts mean fewer potential failure points. Klaus had moved to the engine mount, and his findings were even more disturbing. The Americans have simplified the engine installation process dramatically. Where our mounting system requires 48 hours of precise alignment by master mechanics, this system could be completed in 6 hours by technicians. But the precision is sufficient for the aircraft's performance requirements, Klaus said quietly. They have achieved good enough engineering, but with the advantage of speed and simplicity. Weber walked to the far side of the P-51, trying to process what his team was discovering. Every system they examined revealed the same pattern. American engineers had asked themselves not how perfect can we make this, but how good does this need to be, and how can we make it quickly. It was a fundamentally different approach to engineering, one that Weber's Germanic training told him was inferior, but one that his rational mind was beginning to recognize as potentially superior for warfare. "Bring me the production analysis charts," Weber said, his voice tight with controlled emotion. Friedrich appeared with a folder thick with intelligence reports gathered from various sources, captured documents, interrogated prisoners, reconnaissance photographs of American factories. Weber spread the papers across a workbench, and what he saw there shattered another piece of his engineering philosophy. The North American Aviation Factory in Inglewood, California, had produced 1,329 P-51 Mustangs in the month of June alone, in a single month. Weber stared at the number, certain it was a typographical error. "Friedrich, verify this figure." "Already confirmed, Herr Weber."
Multiple sources.
"And the number has been increasing monthly." Weber's hands began to shake slightly as he performed quick calculations on a piece of paper. His factory, one of Germany's most advanced, had produced 23 Messerschmitt fighters in the same period. The Americans were producing 57 P-51s for every Messerschmitt they built. "This is impossible," he whispered. "Quality engineering cannot be rushed. Precision takes time." But Heinrich was examining photographs of the American assembly process, his face growing paler by the minute. "Hans, look at this. They've organized their production line so that each worker performs one specific task repeatedly. No worker needs to understand the entire aircraft, they just need to master one small part of the process." Werner nodded enthusiastically. "And look here, they've designed the aircraft so that major assemblies can be built in parallel. Wings in one section, fuselage in another, engine installation in a third. Then everything comes together in final assembly. While we," Klaus added grimly, "build each aircraft from start to finish, with craftsmen who must understand every system, every component, every tolerance." Weber felt the walls of his engineering temple beginning to crumble. He walked back to the P-51, running his hands along its simple, functional lines. For the first time, he forced himself to see it not as crude American workmanship, but as something far more threatening, a design philosophy that prioritized effectiveness over elegance. "There's something else," Friedrich said hesitantly.
The cost analysis.
Weber turned, dreading what he was about to hear. "According to our intelligence, the Americans are producing each P-51 for approximately $50,000. And our Messerschmitt? 85,000 Reichsmarks, which at current exchange rates." Weber closed his eyes. The Americans were not only building aircraft faster, they were building them cheaper, much cheaper. Heinrich set down his measuring instruments and spoke what they were all thinking. "They have found a way to mass-produce aircraft that perform as well as our handcrafted fighters, but at a fraction of the cost and time." The silence that followed was deafening. In that moment, Weber realized they weren't just analyzing an enemy aircraft, they were witnessing the birth of a new industrial philosophy that could render their entire approach obsolete. "But quality," Weber started, then stopped. What was quality? Was it the perfect finish on a component that took a master craftsman 3 days to complete, or was it an aircraft that could be in combat 3 months sooner, defending German cities or attacking Allied bombers? Klaus had moved to the propeller hub, and his voice carried a note of grudging admiration. "Look at this bearing assembly. In our aircraft, we machine these bearings to tolerances of 0.001 inches, and each one requires individual fitting by a skilled technician. But the Americans have designed their bearing assembly to accept tolerances of 0.005 inches, 5 times looser." "That's completely unacceptable," Weber began. "But it works just as well," Klaus interrupted. "The looser tolerances mean the parts can be manufactured on standard production machinery by workers who learned their jobs in weeks rather than years, and the functional difference is negligible." Weber felt something cold and terrible settling in his stomach. The Americans had found a way to achieve 95% of the performance with 20% of the effort, and in warfare, where numbers mattered as much as individual capability, that was potentially decisive. Werner was examining the electrical systems, and his findings continued the pattern. The American wiring harnesses are much simpler than ours. Fewer circuits, less precision in routing, more standardized connectors, but the systems function perfectly adequately. "They've eliminated complexity wherever it doesn't add meaningful value," Heinrich observed. "This is systems thinking on a scale we've never attempted." Weber walked slowly around the dismantled P-51, seeing it now with completely different eyes. This wasn't crude American engineering, this was a revolutionary approach to design that he had been too proud to recognize. The Americans had asked themselves a question that German engineers had never considered: what is the minimum performance required, and what is the maximum production rate possible? "Gentlemen," Weber said, his voice barely above a whisper, "I think we have been fighting the wrong war." The team looked at him with confusion. "We have been trying to build the perfect aircraft," Weber continued, "while the Americans have been trying to build enough aircraft to win, and quantity, it appears, has a quality all its own." Friedrich brought over another intelligence report, this one from a Luftwaffe squadron commander on the Western Front. Weber read it aloud, his voice growing quieter with each line. "In January, we faced American fighter squadrons equipped with older P-40 Warhawks, inferior aircraft that our experienced pilots could defeat consistently. And by March, these same squadrons were flying P-51 Mustangs. By June, they had twice as many Mustangs as they had P-40Cs just 5 months before. Our pilots report that for every American aircraft they shoot down, 2 more appear within days. German losses, meanwhile, require months to replace." Weber set down the report and looked at his team. "We have been crafting individual swords while the Americans have been forging an army." The implications crashed over him like a wave. Every hour a German craftsman spent perfecting a single rivet was an hour the Americans spent building 3 aircraft to merely adequate standards. Every day a Messerschmitt spent in quality control was a day 3 P-51s entered combat. "The mathematics are brutal," Weber said, walking to the blackboard mounted on the factory wall. "If an American pilot in an adequate P-51 has a 60% chance of defeating our perfect Messerschmitt pilot, and if they can field 4 P-51s for every Messerschmitt we produce." He wrote the equations on the board, his chalk clicking against the slate with mechanical precision. The numbers told a story that his pride didn't want to accept, but his engineering mind couldn't deny. Heinrich spoke the conclusion they all dreaded. They win through mathematics, not through individual superiority. Weber stared at the dismantled P-51, and for the first time in his career, he understood that engineering excellence wasn't about achieving perfection, it was about achieving the optimal solution for the specific problem. And the problem of winning a global war had a very different optimal solution than the problem of building the most beautiful aircraft. "Mein Gott," he whispered, "we have been so focused on winning individual battles that we forgot about winning the war." The factory sounds around them, the careful tapping, the precise measurements, the slow, methodical assembly suddenly seemed like funeral music for a philosophy that could no longer survive in a world where industrial capacity mattered more than individual craftsmanship. Weber removed his glasses and cleaned them slowly, his mind reeling with the implications of what they had discovered. Everything he had believed about engineering excellence, everything his father had taught him about quality and precision, everything that made him proud to be a German engineer was not wrong, but it was no longer sufficient. The Americans had changed the rules of the game, and Weber was only now beginning to understand how completely those new rules favored quantity over individual quality. Outside, the sound of Allied bombers passed overhead, American bombers escorted by American fighters, all built with the philosophy he was only now beginning to comprehend. Weber looked at his team and knew that their world, the world of careful craftsmanship and individual perfection, was ending. And the Americans were ending it with mathematics, mass production, and machines that were merely good enough. 3 weeks had passed since Weber began his analysis of the captured P-51, and the German engineer had barely slept. His office was now covered with charts, calculations, and diagrams that told a story his mind was still struggling to fully accept. But tonight, as he sat alone in his factory long after his workers had gone home, something finally clicked into place. Weber stood before the blackboard where he had written a simple equation that changed everything. Quality garture, quantity garture, time equals sign victory. For 30 years he had focused only on the first variable. The Americans had mastered all 3. The sound of footsteps echoed through the empty factory. Heinrich appeared in the doorway, his face drawn with exhaustion and something deeper, the look of a man whose fundamental beliefs had been shaken. "Heinz, you've been here all night again." Weber nodded without turning around. "Heinrich, what if we've been asking the wrong question all along?" "What do you mean?" Weber turned to face his oldest colleague, his eyes bright with the intensity of revelation. "We've spent our entire careers asking, how can we make this perfect? But the Americans asked, how can we make enough of these to win?" Heinrich moved closer to the blackboard, studying Weber's late-night calculations. "You think their approach is superior?" "I think their approach is optimized for the actual problem they needed to solve." Weber picked up a piece of chalk and began drawing. "Look at this. If a perfect Messerschmitt has a 90% probability of defeating any Allied fighter, but we can only produce 10 per month, what happens when the Allies field 100 fighters that are only 70% as capable individually?" Heinrich watched as Weber worked through the mathematics on the blackboard, his engineering mind following the logic even as his pride resisted the conclusion. The mathematics are brutal, Weber continued. Even with individual superiority, we lose through attrition. But here's what's truly brilliant about the American approach. They didn't just solve for quantity, they solved for the entire system. Weber moved to another section of the blackboard where he had mapped out the American production philosophy. They designed their aircraft not just to fly well, but to be manufactured efficiently, maintained easily, and replaced quickly. They optimized for the entire life cycle of warfare, not just individual combat performance. But surely quality matters. Quality matters enormously, Weber interrupted, but only up to the threshold where it achieves the mission. Beyond that threshold, additional quality becomes a luxury that warfare cannot afford. Heinrich studied the charts covering Weber's office walls, production timelines, cost analyses, pilot training requirements, maintenance schedules. Together, they painted a picture of American industrial thinking that was far more sophisticated than either German had initially realized. They didn't compromise on quality, Heinrich said slowly, understanding beginning to dawn in his voice. They redefined what quality meant in the context of total war. Weber smiled, the first genuine smile he had managed in weeks.
Exactly!
A P-51 that can be built in 3 months and maintained by mechanics with basic training is higher quality, in warfare terms, than a Messerschmitt that requires 6 months to build and can only be serviced by master craftsmen. But Hans, Heinrich's voice carried a note of anguish, what does this mean for everything we've built here? For our entire approach to engineering? Weber walked over to the P-51, now fully disassembled and analyzed down to its smallest components. He ran his hand along one of the wing panels, simple, functional, effective. It means we need to evolve, Weber said quietly. The Americans have shown us that there are different kinds of excellence. The excellence of the craftsman, which we have mastered, and the excellence of the system, which they have mastered. So we abandon craftsmanship? No, Weber said, his voice gaining strength and conviction. We integrate it with systematic thinking. We ask ourselves, where does precision craftsmanship add genuine value, and where does it simply slow us down? Weber moved to a clean section of the blackboard and began sketching rapidly. What if we redesigned our production process to combine German precision where it matters most with American efficiency where speed matters most? Heinrich watched, fascinated, as Weber outlined a hybrid approach. Critical flight components would maintain German precision standards, while secondary systems would adopt simplified, mass-producible designs. Assembly processes would be streamlined using American techniques, but quality control would retain German thoroughness at key checkpoints. Selective precision, Heinrich murmured. Intelligent compromise. Not compromise, Weber corrected. Optimization. We optimize for the real goal, victory, rather than for abstract perfection. Friedrich appeared in the doorway, carrying urgent dispatches from Luftwaffe High Command. Weber took the reports and read them quickly, his expression growing grim but determined. Production requirements have been doubled, Weber announced. High Command wants 46 fighters per week instead of 23. Heinrich's face went pale. Impossible. Not with our current methods. Weber looked at his colleague, then at the dismantled P-51, then at his blackboards covered with calculations and revelations.
In that moment, everything crystallized.
Heinrich, what if I told you we could produce 50 fighters per week, maintain our quality standards where they truly matter, and reduce our production costs by 30%? I would say you've lost your mind. Weber grinned. Then let me show you how the Americans have already proven it's possible. For the next 2 hours, Weber outlined his vision. German engineering excellence would be focused like a laser on critical systems, engines, flight controls, armament. Everything else would be simplified, standardized, and optimized for rapid production. Workers would specialize rather than generalize. Components would be designed for ease of assembly rather than individual perfection. The Americans taught us that quality is not absolute. It's contextual, Weber explained as he drew organizational charts on the blackboard. A rivet that takes 3 hours to install perfectly is inferior to a rivet that takes 30 minutes to install adequately, if both rivets perform equally well in combat. Heinrich was beginning to nod, his engineering mind engaging with the possibilities. We could maintain our precision culture while adopting their efficiency methods. More than that, Weber said, his excitement growing. We could potentially surpass both approaches. German systematic thinking applied to American production philosophy, combined with our traditional precision, where it genuinely adds value. Friedrich had been listening from the doorway, and now he stepped forward. Herr Weber, the colonel wants to know when you'll have your recommendations ready. Weber looked around his transformed office, at the analyzed P-51, at the blackboards covered with new equations, at the charts showing American production capabilities. Everything that had once challenged his worldview now felt like tools for building something better. Tell the colonel I'll have a complete proposal in 48 hours, Weber said. And Friedrich, tell him we're not just going to match American production rates, we're going to show him how German engineering can exceed them. As Friedrich left, Heinrich remained, studying Weber's diagrams with growing amazement. You really think this can work? Weber moved to the window overlooking his factory floor. Below, the machine sat silent in the darkness, waiting for tomorrow's shift of craftsmen who would continue building beautiful, perfect, slow aircraft using methods that were no longer adequate for the war they were fighting. Heinrich, 3 weeks ago, I believed that German engineering was superior because we built perfect machines. The Americans have taught me that German engineering can be truly superior by building perfect systems. And the difference? Weber smiled, and in that smile was the confidence of an engineer who had found the solution to an impossible problem. A perfect machine serves only itself. A perfect system serves victory. Heinrich looked at the P-51 one final time, but now he saw it differently. Not as a crude American compromise, but as a revolutionary approach to engineering that had forced them to evolve beyond their previous limitations. So what do we call this new approach? Heinrich asked. Weber thought for a moment, then wrote on the blackboard in large, confident letters, Strategic Excellence, Engineering for Victory, not Perfection. Below that, he added, Quality where it matters, efficiency where it counts, speed where it wins. As the two engineers stood in the quiet factory, surrounded by the evidence of American innovation and German analysis, Weber felt something he hadn't experienced in weeks: hope. The Americans had won this round by changing the rules of the game, but rules, once understood, could be mastered by anyone with sufficient intelligence and determination. And Weber was about to prove that German engineering, properly applied, could master any rules, even ones invented by their enemies. Outside, the dawn was beginning to break over Regensburg. Soon, his craftsmen would return to build another day's worth of perfect individual aircraft, but within 48 hours, Weber would present them with a new vision how to build victory itself, one efficiently perfect system at a time. The age of beautiful, slow perfection was ending. The age of strategic excellence was about to begin.